And let's now hand over to Shane to kick off Modo Live. Let's have a round of applause.
All right.
Thank you.
Awesome. Well, thank you, everybody. Great to see a huge audience here tonight, and I'm sure a huge audience online as well. As you know, or as you just heard, I'm Shane Griffith. I'm from the Foundry. A little bit about a couple important things that you're going to notice throughout the keynote tonight. One of the things that we're doing, and we're kind of in the process of rebranding the Foundry to just Foundry, as you see here. So some of our new graphics you're going to kind of get a first glimpse at as we start to roll out the new brand in the coming months and so on. Tonight we have an amazing lineup of really, really talented artists from a lot of different industries, a lot of different backgrounds. I think 8 in total tonight. And I think you're going to see some really amazing stuff and see Modo in action in really amazing ways tonight. So I wanted to first kind of give you a recap. I think last year was a really great success for us with the 10 series. We launched, as many of you know, 10.0, 10.1, 10.2. And really we're able to release not only a much more consistent product throughout the year doing it that way, but also a lot more value in the total sum of what we were able to do in the full year. Coming up in a few days, in a few weeks, we'll cap out the 10 series with a 10.2 V2 release, and that'll have a few additional bug fixes and things like that, so look for that in your updates folder here pretty soon. We've had a number of kits and plugins and trainings released this year, even 3 of them that were completely free. One of those of mention is a Sketchfab plugin, which enables you to take your Modo content, directly upload it to the web, and view it from any browser anywhere in the world in a full 3D environment without any additional plugins. So really, really cool stuff. We've expanded kind of the partner portfolio dramatically in this last year, and I really look forward to doing that additionally this year as we move forward. We've seen lots and lots of great artwork by lots of users out there. We're starting a lot of campaigns around that with the Made for Modo campaign, where we're tagging those and getting a lot of recognition. So if you're out there posting stuff, I highly encourage you to use that hashtag as well. This year, we're going to continue on improving on the webinars, the training, the online sessions, things like this. We want to do a lot more of to get the information out there, help educate you in better ways and more direct ways. So again, look for a lot more of this as we go forward. And then we're nearing into, as I said, the end of the 10 series with the 10.2 V2 release. And we will continue that same pattern as we move into this year with the next series of releases. We'll probably do a 3-part series again. So look for that kind of spread out through this year as we kind of move forward going into this year. I wanted to thank our very generous sponsors here tonight. Pixel Fondue is one. I think 3 out of the 8 speakers tonight are contributors to Pixel Fondue. They do an amazing job, again, of putting great information out there. If you're looking in new ways to learn, sample files, content, it's an excellent site to go to. Sketchfab, I've already mentioned. ArtStation, we're doing a number of things there with challenges and contests, and we're going to continue to press that more this year. Gnomon for hosting us tonight. It's a fabulous facility, great technology for streaming us live. And then Wacom for also providing awesome technology for our artists, not only on stage, but across the world to really, again, bring that immersive artistic environment to Modo. So without further ado, I'm going to kick off tonight's presentation with the first section on Modo in design. And our first speaker up tonight is Kevin Ketchum. Kevin works for us here at the Foundry. He's been here about a year now. He specializes a lot in the automotive space. Kevin is an industrial designer by training and trade and education, a fabulous artist overall, and he's really adapted a lot of his skills to an entirely new platform, which is Modo. So he's made some really key learnings and going to show you some pretty cool tips and tricks on things that he's picked up just in a year's time picking up the product. So without further ado, here you go, Kevin.
All right, thanks, Shane. Well, again, as Shane mentioned, thanks, Gnomon, for having us. As Shane was mentioning, I've seen quite a transformation from the automotive studios using typical tools like NURBS and regular CAD modeling, and this insurgence of polygon modeling just infiltrating all the studios. And when I saw Modo for the first time, I just saw one word, which was the retopology tools is why Modo is getting into the global automotive studios. And so for the next 8 minutes, I'm going to kind of run you through the day in the life of a designer and what his output has to be and why the value and the effectiveness of Modo can support the demands of an automotive studio. So a designer works pretty good in 2D lines, but he usually doesn't start with a clean slate or blue sky. He typically has some sort of criteria, some sort of Oscars or packaging that he has to work with, but he's pretty good with the pen and knows a good curve when he sees one. So he can craft those lines, a vector line in side view, but also those that are adventurous enough to do them in 3D or sculpt them and create basically what I'd call a curved network. That way you can master each line. The cool thing about that is you can leverage that right over in Modo. So, you know, I didn't know that you could do this, but I took those curves and brought them over as DXF files and allowed the designer, and I'm seeing the designers drape a polygon canvas over this framework with complete and total disregard to any kind of Class A surfacing or gilt. And quickly, they're rapidly, you know, closing the volume, and that's really what they want to see. It was just 2D lines, but a designer doesn't have time to sit there and noodle and craft every fillet and radius. So the ability to use the retopology tool and drape canvases over these wire frames is really a big time saver. And then using the advanced viewport capabilities now in Modo 10 series, be able to put a mirror up to one half of it and start doing paintovers. So another output that Modo can consume quite well is scan data. So a designer is doing 2D line work. He's also supporting the clay modeler who is out on the floor, and he's giving him direction, 2D line direction. He's putting knife lines or, you know, tape on the model. Well, those models get scanned every so often and brought into the tube. So this data usually is not exactly at the 0, location or, you know, world space. And I did have an extreme example that it's upside down and backwards in the middle of nowhere. So being able to plant it on the ground with basically hardly any effort using, the polygon tools, the retopology tools to place it on the ground, clean it up, and then quickly look at the exterior surfaces. Are the corners too sharp? Are they too bulbous? And so usually when a scale gets blown up, all those fillets get redone anyhow. So inspection tools, like looking at that clay. Well, is it a good surface? Should we do it again? Those things are very valuable to the math modelers or creative digital sculptors. And sometimes guys just use like a material capture or a ball map, or they use more of a procedural attack and look at the surfaces for the convex and concavity of the surface. And being able to check for some sort of draft angle, like how good is the draft on this clay? Well, I didn't know about Modo's draft tools, and so I put a 3-degree draft, an alias, and a 3-degree draft off of Adam O'Haron's little cool training, by the way. And polygon for polygon, it showed up exactly the 3-degree. It revealed the shoreline to be the same. In addition to that, being able to see curvature, continuity, and the convex and concave surface development to allow you to develop your primaries and secondary surfaces for when it's handed off to CAD modelers that need to spend a lot of time making it manufacturable. And also to be able to flatten out the perspective on a camera, Modo was able to do that. And in the 10 series, as Shane was mentioning, just one of the, I think, a pretty awesome tool that just came out is this auto retopology. But how does this affect a designer in a clay studio? Well, the clay usually gets scanned, and it's a heavy, heavy mesh, like uniform tessellation. The tessellation has nothing to do with the shapes or the forms of the model. And the tightest little radius, that triangle is what gets propagated across the whole model. Well, the designer now has to take his clay and send it off for preliminary aero testing. So using the auto retopology tool and giving it some intelligence such as edge flow, meaning I want the highlights to flow like this. I'd like the quilt work of polys to kind of follow the character of the theme, and also edge lock. So there's some areas that are tricky, like hard wheel flanges and holding hard detailed lines. So using flow and lock in the auto retopology tools allow that to happen. And the tools, we're seeing that guys are like, getting a lot of output through this. And depending on the scale of the model, because some of the settings need to be dialed down or up depending on how large the model is. But basically, it helps you decimate the model, shrink wraps a quad quilt over the whole thing, and then I take that and And I've shown designers how to take that auto-retopoed mesh and shrink it back over the original clay, so you can kind of shrink it back down to kind of guide and give it some correction if you see any kind of misalignment. And then also to use the push tool up against a predetermined size cylinder to help kind of correct some of that. So I just using my pen tool, most designers can use a Wacom tablet, as mentioned, and just push that into that diameter wheel. And by doing that and using the already strong topology tools that are inside of Modo, you've got quite a skill set. But now the designer has been requested, hey, the clay has changed and the engineering package needs to be updated, plus we have new information. So using the contour tool, again, in the retopology tools, I can cut sections at predetermined locations to feed the engineering drawings to keep making sure that we're not impinging or cutting into the occupants. So it's a communication tool, these lines. And then because Modo has FBX output, you can output that into a CAD package and create sections and propagate it and keep the whole engineering community informed. Meanwhile, the designer has gone back to his desk and taken the clay using the real-time ray tracing and progressive renderer. He's going to be doing screen grabs and doing Photoshop paintovers. The cool thing about this is I didn't have to leave Modo to go do a killer rendering. I'm going to grab the clay, go into Photoshop or whatever the application their preferred weapon is and Frankenstein it out. They're really good in 2D. So that clay model is coming along, and now we need to see a scale model. And again, in the Modo 10 series, we came up, and the team is really talented. Procedural mesh fusion. All right, procedural modeling, leveraging the power of mesh fusion. These parts can be generated, hard surface parts. It's not a it's not a dead model, right? It's live. It's interactive. It can change at the speed of conversation. So be able to create a 3D watertight part and go back and make a change and say, oh, it's a different bolt pattern, and be able to output a watertight mesh is so powerful. And anybody that knows any polygon modeling, when you leave it, it's dead. With this, it's live, and you can go back and reactivate it at any time and be able to crank out imagery. So here we are at the end of it all, coming together, Modo, the scan, the surfacing, and creating powerful imagery. And the way that you can tell a good piece of software is how strong is the community. And these images that you're seeing are from our Modo user community. Product designers, freelancers, guys working in studios, creating advertising, they're all coming together, and that's what I really love, and what I noticed about coming to Foundry was this community. And these images, as you're seeing, are very compelling. And talking about the community, the contest that we just had, the test driving Modo, test driving Mari, these are some of the top submissions that just came in. And I'm pretty excited about it, and we're seeing the proliferation of Modo in every one of the automotive studios around the globe. And this is pretty compelling imagery. I think for new users, it's fantastic. So with that, thanks a lot.
So thanks, Kevin. I think one of the really cool things that Kevin is able to show is how Modo is so diverse in its modeling approaches, between curve modeling, surfacing, solid modeling, to procedural modeling. It's really, really all there. Even sculpting, you don't have to leave the application to another tool to do those things. Or if you are using another application, it's accessible as well. You could bring that data in and leverage some of, something that may be more of a games type tool with the retopology section of the features. It still do curve modeling on top of that.
Right.
So
exactly.
Really, really cool stuff. It's just fantastic. Thanks, Kevin.
Thank you, Shane.
So next up we have Ed Ferrari. Come on up, Ed. So Ed has been using Modo about 3 years now, right?
That's about right, yep.
About 3 years. Ed is just kind of an amazing individual. He's not necessarily a professional 3D artist. He's
right.
actually an actor, a stand-in of all things. So he's not standing in tonight. He's actually representing a true artist and a freelancer aspect of things. Ed was just a great contributor to the community. He really, really latched on to Mesh Fusion when it came on early, dug in there, and then when we revamped kind of the UI for Mesh Fusion in 10.2, he was one of the first kind of on board to get in there, and dig deep and really understand it. So Ed has like an enormous library of Mesh Fusion training tutorials and other short clips and stuff on Pixel Fondue. And I really wanted to bring him up here to kind of just speak towards how it just has fun with Modo in general. It just does lots of fun things with Modo. So yeah, Ed's going to give you a short demo on some of the things that he likes to do with Mesh Fusion and procedural modeling. So take it over, Ed.
Cool. Thanks, Shane. Yeah, absolutely. As Shane mentioned, my name is Ed Ferrari. I'm a freelance 3D artist, and I'm also a contributor over at Pixel Fondue. And I'm also just a Modo enthusiast. So today I'm going to demonstrate a technique that I use for designing ornate objects with Mesh Fusion and procedural mesh operations. And I'm going to design this ring here. So I have a scene open in Modo, and there's a few mesh items you'll notice, and they're all very simple, basic, almost primitive shapes. So here we have a cylinder. I have a pair of blocks with one edge on each, sort of rounded. Then I have that tall block, and we're going to use those to create this ring. And then I'm also going to cover how to create the face of the ring and get this ornate pattern. So the first thing I'll do is select the topmost mesh item, and I'm going to come over to the Fusion Vertical tab and create a new mesh item, or new Fusion item, and I'm going to name it Fuse_ring. And you'll notice that we have a Fusion item here, which is highlighted in white, and we also have this Fusion source, which has a green wireframe. Now, just as a refresher for Mesh Fusion, the green wireframe is a primary or additive operation, whereas the magenta wireframe and purple wireframe are trim operations. The magenta will subtract, and the purple will be an intersect operation. And seeing this in action will speak volumes. So I'm just reactivating the Fusion item. I'm turning on Deferred Update, and I'm changing the mesh mode to Airtight Final. And then I'm just going to take the cylinder, I'm going to left-click on it, and drag it onto the primary. And that will bring up this palette, and I'm just going to choose Fusion Apply Subtraction. And there you can see the cylinder is now being subtracted from the primary. And you'll also notice that the wireframe of the cylinder is magenta. So everything is nice and color-coded. And now I can just adjust the subtractive element. And you'll notice that the Fusion is only updating when I mouse up from the Move tool. And that's because deferred updates are activated. So I'm also subtracting this pair of cubes, so they also get the magenta wireframe. And now this tall block is going to be a let's see, this is going to be a mesh operation. It's going to be a trim as well. So I'm just going to go to the add operator in the mesh operation stack, and I'm going to add a vortex effector because I want this tall block to be flared towards the bottom. So I've selected the vortex effector, and now I'm just going to move and scale and rotate it so that it roughly fits the size of the tall block. And again, what I'm going to do here is just get it to flare. So with the vortex effector selected, I'm going to go to the properties, and I'm going to select taper per unit, and then I'm just going to adjust the taper so that it flares. And then I'll left mouse button, click and drag on the block, and drag it onto the primary, which is the green wireframe. And I'm going to choose Fusion, Apply, Intersect. And then I'm going to press Control F to bring up the Fusion Pie menu, and I just selected Disable the Fusion Sources, so that we can get rid of those wireframes. Now, the one thing I don't like about this is the top is very flat. So I'm going to come over to the Cubic Geometry preset browser and choose a sphere. Now, the cubics are all quad, all Catmull-Clark subdivision surfaces that are tailor-made for working with Mesh Fusion. I'm just going to come into the shader tree and delete the material group that comes with it just to keep everything nice and tidy. And then I'm going to select all the polygons from the sphere, scale it all the way up, and then just move it down. And since this is going to be an intersect fusion operation, everything within the sphere will be maintained, and everything on the outside of the sphere will be trimmed away. So when I left mouse button click and drag on the sphere and drop it onto the primary and choose Fusion Apply Intersect, you'll see that the top is now slightly rounded instead of being so flat. So another great thing about Mesh Fusion, and this really differentiates Mesh Fusion from regular Boolean operations, is the idea of strip items. So strip items are kind of they're created with the Fusion item, and they occur wherever a Fusion source item intersects with another Fusion source. So by clicking on a strip, we get this Fusion Strips menu, And then in the properties, I can change the strip width and strip profile. And it's almost like working with live bevels. So you can I'm changing the strip width right now to 25 millimeters. And this ring isn't built to scale. What I usually like to do is work at the default scale, and then at the very end, I'll just use Modo's absolute scale tools to scale everything down. So now I'm going to select all of the strips that kind of meet at a corner point. And you'll see the corner right here. And then I'm going to go into the Fusion Strips menu right here, and I'm going to twirl down this strips corner. So I have this row of icons. The leftmost one is a square, and the rightmost one is a circle, and then in between is a gradation between square and circle. By choosing the circular icon, you can see the corner becomes very rounded. By choosing the leftmost square, it's very angular. And then I'm going to choose the third from the left because that's like a happy medium. And with that, the body of the ring is done. So now we're going to work on the actual design. So here's the ornate design. What I'd like to do is create these patterns. Now, the colors are not arbitrary. I'm actually thinking about Mesh Fusion as I design. So the green represents the positive aspect, and then the magenta is the part that will be trimmed away. So I'm going to open up a scene that's available to all Modo users who have access to the 10 series, and it's called the B-Spline template scene. So I go to Help, Kit Help, pFusion Toolkit Help and Files, and then open pFusion Template Scenes folder. And I'm going to click on the B-Spline template scene. Then I'm just going to go into the front view. I'm going to deactivate this circular curve, create a couple of empty mesh items, and then by clicking on this little rectangle right here, it brings up this form called the B-Spline edit form. And these are full of really great scripts that were written by Darrell Anderson. He's the co-author of Mesh Fusion. And these are just really great for working with B-splines. So I'm also going to create a backdrop item. And then in the backdrop item properties, I'm going to go to Image, Add Clip, and then I'm going to load the image, the square knot 001. Now it comes in very large, so I'm going to go to use uniform size, and then I'm going to increase the transparency to 50%. Now, in one of the empty mesh items, I'm just going to trace out these magenta shapes with the B-Spline tool. So the B-Spline tool is new to Modo 10, and it's really great. I'm not trying to be too precise here, and then by right-clicking on the first point, it closes the curve. Now I'm just selecting all of the vertices that I want to be sharper or corners, and I'm going to choose the 3-point corner script. And then by choosing 3 of those vertices, I can choose the round corner more script, and it just rounds them a little bit more so they're not as harsh. So now it looks like I have a lot more tracing to do, but these curves work with the procedural system. So I'm in the Mesh Operations tab right now, and then I'm going to add a radial array in the procedural stack, and then I'm going to expose the radial array tool pipe and get to the helix generator properties so I can change the axis to Z and the count to 12. And now you'll notice that it just created 11 more of those lightning bolt shapes. So now I've skipped ahead a little bit. This is probably like 25 or 20 minutes further down the line, and I have the entire design complete. And I'm just going to show you 2 ways that you can save this. If I right-click on the mesh item and go to Presets, Save, that's one way. I can also go into the B-Spline edit form, and at the very bottom I can choose Prep and Save Preset. And the advantage to doing it this way is it actually creates a nice thumbnail. It just renders a 512 by 512 image that you can use as a thumbnail for your preset browser. So to put this in your preset browser, you just go to System, Open Content Folder, navigate to the folder where you want your presets to exist, and then you open up your documents where you saved that preset and just drag that recently saved preset into your preset browser folder. Okay, so now I'm going to assign that design that we just created to the ring. So I need a few different things. I'm definitely going to need a 1 meter sweep curve, which is right here, and I'm also going to need a few designs. So the 1 meter sweep curve is just a B-spline path that's straight in the y-axis. I'm also going to bring in the square knot right here, which is what we just created. And then I'm also going to bring in the square Aztec 002 and square swirl 007 designs. So I'll also just keep my scene tidy by deleting the material groups. And then I'm going to take the 1 meter sweep curve and just move that in the Y so that it's just penetrating the top of the ring. I don't want it to go all the way through the band of the ring. And then I'm going to take all of my top designs and snap them to the very top of the sweep path. And then I'm also going to group these designs. So I'll call it GRP for group underscore top underscore patterns. I'm also going to create another mesh item, and this is going to be called MRG underscore top underscore patterns. Now, this is going to be a merge meshes mesh operation. The merge meshes mesh operation is one of the coolest things in the Modo 10 series. So I'm going to add an operator, and I'll choose merge meshes. And by exposing the sources of the merge meshes, I can add a source. Now, I'm going to use the square knot 001 pattern. And then on top of the merge meshes mesh operation, I'm going to create a curve extrude. And it's going to ask me for a path. And I'm going to use the 1 meter sweep curve. And I'll see what happens is the pattern is swept along that path. And I'm just going to activate curve cage so that the sweep geometry isn't so dense. And then I'm going to deactivate the cap start and cap end. Now, you'll see why I'm using a merge meshes mesh operation in a few minutes, and it's going to be pretty cool. So you might be thinking, why don't I just drag the sweep geometry onto the primary so that it subtracts? And I could do that, but I'm not going to. And the reason is because if I do that, there's going to be a hole trimmed in the bottom, and I want to keep the band of the ring a solid piece. So what I'm going to do is I'm going to create a new fusion item, and I'm going to take advantage of something in Modo 10.2 called the compound trim feature. And it really supercharges mesh fusion. So in order to do that, I'm going to create a new fusion item based off the sweep geometry. And the compound trim feature basically allows us to subtract one whole fusion item from another fusion item. So I'm going to need to trim the bottom of this sweep geometry. So I'm going to use the sphere, which we previously used to round the top of the ring. And I'm just going to reuse it to trim away at this sweep geometry. But first, I'm just going to use a push influence to kind of scale down the sphere. And I'm just using a distance of negative 75 millimeters. And now that it's the size that I want, I'll left mouse button click and drag it onto the sweep geometry and apply subtraction. And by clearing the fusion source items, you can see that it caps the bottom, but it actually inherited some of that roundness from the sphere. Okay, so here's the fun part. I'm going to select either of the fusion sources for the second fusion item, and I'm going to create a compound trim. So in the Fusion Vertical tab, under Compound Trim, I'll choose the first icon, and you'll notice a few things have happened. We no longer have the second fusion item in the item list. Instead, it's replaced with a locator, and the fusion sources from the second fusion item are children of that. And the locator looks more like a bounding box that surrounds the fusion sources. So now with the primary item visible from the first fusion item, I'm going to left mouse button click on the locator and then shift select the primary. And then I'm just going to go under set mesh roll and apply and choose the first icon, which is subtract. So now you'll see that the design, that intricate design, has been kind of cut into the ring, but it's not going all the way through. Now, what's really cool about this is that because we used the merge meshes mesh operation, I can return to that mesh operation. And then in the mesh ops procedural stack, I can expose the source. And this is really cool. I can use that little button, that little black circle with the two arrows, to switch the source. So now I'm going to switch to the Aztec design. And every mesh operation that's subsequent to the merge meshes operation actually propagates down the line. So it's taking into consideration the curve extrude, the compound trim, and the subtraction from the first fusion item. So all that work that we did to set up, we can now just take any old design. Even if I make a design later on tonight, I can import it as the source, and now I can just change the design on the fly. It's a super powerful part of Modo 10. So I'm just putting it back to the square knot right here. And here I've gone a little bit further, and I've added designs to the side of the ring. And it's the same technique where I have a B-spline pattern that's being swept along a path. In this case, I'm using a mirror mesh operation, so it's on both sides. And then that whole setup is part of a compound trim that's being subtracted from the fusion item, the original fusion item. So now I'm just showing you a different way to change out the sources. I have the schematic open here. And then this area right here, I have all of my different patterns. At the moment, I have this alien symbol, which is this kind of Y shape with the 3 circles. And that's being fed into the merge meshes. If I want to change it to the flower symbol, like let's say a client doesn't like alien symbols for whatever reason, and they'd rather have a flower symbol, I can just detach or delink the alien symbol from the merge meshes sources, and then just relink the flower symbol, and you'll see that it kind of pops in there. You'll also notice that I have a kind of hollow area right underneath the design. I'm just going to fill that with another geometry that's going to have its own material, just to give some material variation to the ring. But in much the same way I switched out the sources for the side of the rings, I can change the top pattern as well. So here we have the square Aztec 002 design. I'm just going to unlink the square knot and then relink the square Aztec. And straight away, the design has changed. You can literally have as many designs as you can think of, and it'll just change on the fly. It's pretty great. It's a really, really powerful aspect of Modo. It's why I love Modo. So let's say we're happy with this design, and we don't want it to be live anymore. We just want to output actual geometry. So I'm in the Fusion properties, and at the very bottom here, we have dupe and convert to mesh. I'm going to click that and give this mesh a name. I'll just call it ring_A. And now we have actual polygons that we can work with. So here I'm just going to quickly light and rig this. And I'm just going to be pretty experimental because I'm not a lighter or a rigger. But I have the flipped normals lighting scene open. And I'm just in the preset materials for that ship with Modo. I'm just dragging on a platinum material on the body of the ring, and then I'm going to use this Velocity yellow car paint for the inside of the ring. It's not something I think you would typically do, but it's just the type of experimentation that I like to do with Modo. It really just opens things up. And I'm going to use the progressive renderer, and this is sped up pretty significantly. But this is the type of thing that I'll do and just go walk my dogs or go make a sandwich and come back, and maybe something will look great, because with Modo, it's really easy to experiment. So here I have some earrings using the same exact technique that I just showed you guys. There's a different view, and then I have some rings where I've changed the interior. Here's like the LED preset. So yeah, that's the technique. Mesh Fusion is incredibly powerful. Modo 10 was a huge release. So many great things. I want to thank you guys for letting me share that with you. And check out Pixel Fondue.
Thanks, Ed. I really like how you're able to take a base setup, that probably took a few hours' time to generate the original ring or so.
Not
right?
really. I mean, that was almost real time. I mean, it wasn't 2 hours.
That's fantastic. And then you get instant results with the variations, with those different 2D templates and a mixture of 2D design to 3D design with instant results.
Absolutely. And I can even go back to that tonight and just change it some more.
Yeah.
And yeah.
Good stuff.
Thanks.
All right, so up next, no stranger to Modo, we have Yazan Malakash. Yazan's what we like to call a little bit of a magical unicorn. He's an amazing artist, amazing technical person as well, writes plugins, scripts, many additional contributions to the Modo family on that side. An amazing business person as well, owns a couple different businesses, 9B Studios being one of them, co-founder of Pixel Fondue as well. So I'm going to leave it to Yazan to talk some more design and some of the really, really big and amazing clients that he gets to work with on a daily basis. Take it over.
Awesome. Thanks, Jen. Yeah, that was a great introduction. I'll probably bring you along for more introductions like that. Yeah, visit our website, Pixel Fondue, for a lot of new training and sources there. We've got some fantastic people, two of which, Adam and Ed, are in the audience here. So I run a company called 9B Studios, and we do a number of different things. That's our slogan, I guess, what's a weekend, because we're working all the time, or not. We were started in 2009. I stopped for about 3 years when I worked at the Foundry, doing a number of different things in 3D tools. But we have a lot of production and workflow development experience, mainly focus on product design, apparel, and biomedical industries, and on the consulting side, design visualization pipelines. Some of the clients we have dealt with over the years, a lot of just kind of well-known brands, but most of these are coming from the design space, and we're very lucky and blessed to kind of work with these people. We typically start our process looking at what does the client need and where are they going with this, and a lot of times there's different things like simulations and 3D assets and 3D scenes, and some of them are coming from the design companies and some of them are not, and we'll kind of refine that as we go. For this, what we're going to talk about today is specifically more simulation of pattern data. And our output typically, whether it's a render or a design pack or VR web, all that kind of comes in from the publishing side. The project we're talking about today is Under Armour, and we did a project for them called Swacket. It's a sweater and a jacket at the same time. It's pretty cool. You guys get some from their website. We worked with collaboratively with Mike Campau, and he's another Modo amazing artist that does just really good visuals. Some amazing other people mentioned at the bottom as well. I don't know if Jessica's here. Is Jessica here? No, she doesn't make it. No, too bad. This is what we ended up with. It went live on the main site, which was pretty cool for us to see that there's a Modo final render that actually went on there. That was pretty cool. We tackled many things like women's, men's collection, girls and boys as well. And this is the first video they kind of released, kind of showcasing some of their things. Everything was done in Modo, and then this was kind of composited, obviously. Some of the macro photography Mike pulled off like that, and then kind of merged them in After Effects and things of that nature. But it was a great opportunity for us to showcase, because we do some of the consulting on the process and pipelines, to actually do production and learn from that and see how we can optimize that for our clients. Yeah, so that's Swacket. And we'll go through a few processes. These are the final renders. These were done at 8K resolution, which is insane, because we were doing this on a daily basis. Every render took about 40 minutes. We were dealing with this on a brand new box tech machine with like 40 cores, and Modo was just chugging through. What was interesting to me was it was the first time we were actually going back and forth with our clients at 8K, because what the feedback was before is like, oh, maybe the lighting is off. Now it's like, oh, the stitching needs to be double stitched instead of single stitched, because we were going and focused to that detail and that level. And that was the first time for me to kind of go through that process, even from just this image. Or they might say, the fleece needs to be done. So there's actually, we're using fleece, Modo fur, displacement, replicators, water drops. I mean, I threw everything I can on this project just to see how much we can chug through, and it just went through it, which was pretty cool. And every time we kind of swap out the different patterns, there's more details to be added. So you can see here, we had to do it both open and closed. And while it's the same pattern simulation, we did have to kind of change some of the things around. And obviously, some of the wrinkles and things like that would change from one part to another. And this is the pipeline we used for our production. So Clo 3D, it's basically the CAD version of Marvelous Designer, if you guys have heard of Marvelous Designer. And we use that for all the pattern simulation product. And then we moved over to ZBrush for any kind of detailing on top of the actual simulation. Sometimes you just don't get the wrinkles and the fabric properties that you want. Modo was our pipeline tool in this case. I mean, think of it as when you're doing a visualization, something has to feed somewhere so that all your assets come into one place and you can actually export and publish from that. So Modo was the place we posed, we modeled, lit, shaded, and rendered our final scene. Photoshop and Illustrator, textures, and Illustrator, we use that a lot for the stitching and piping for the products. And all of that, like I said, all the assets came into Modo, and we kind of used all that to build up our scene. It was pretty interesting. This is what we typically start with from our client. So simple sketch, this is what we want. We'll get a brief. We want to get some product brief from the client, and maybe some colorways that are line art in Illustrator. And then we'll start kind of dropping them inside of Modo and looking at what the posing is like and all that. So you can see here we've got a human figure. We started to pose it. And we'll go through this iterative process with the client because they're thinking in 2D and what the results will be in the end. And we have to deal with the three-dimensionality of it. And it's not an easy thing for them to kind of understand what all the possibilities are. Kind of going through the process, this is our pattern creation process inside of Clo. So on the opposite of UV mapping, which is basically you start with a pattern and then you simulate it on top as opposed to modeling and then unwrapping things. What makes this interesting is that this is exactly how you would work in the real life, right? So this makes a ton of sense. The mannequin is more of kind of in place to get the shape that we were looking for initially with the client. And a lot of this is just literally you're just grabbing the fabric and moving it along on the surface to make sure that the fit and the feel is the same. And we'll go through a process of going from realistic fitting to kind of abstract fitting, depending on what the client wants. But this is what the avatar would initially start off as, just to make sure that the pattern looks right. Do we have all the seams in there? Is it double seam stitch or whatnot? And we'll put an avatar just for reference of scale for the client. Same thing for women's or any kind of other cut that we need. So tons of work here initially, but then we go, okay, so what kind of pose do you want? Oh, well, like he's kind of running, and we'll go, okay, here's what it looks like with the avatar. Obviously, they don't want the avatar in this shot, and they're like, yeah, it's too much. Maybe it's a jog. It's not so much running, and we're like, okay, so we can. So that flexibility comes to play, right? That the clients now see the potential and the flexibility of what you're able to do that they didn't have before, and they're like, well, maybe they need to jog on the left side, and then you flip it over, and because it might be an asymmetrical model. And then you keep on iterating and iterating and kind of changing. Okay, we don't want jog or run, maybe a power walk, but keep it on the left side. And we went through that over and over. It was a challenging timeline to fit all that. But again, being able to grab the avatar, repose in Modo, or repose it in Clo, and then do the simulation again, that back and forth, for us, it was kind of flexible. For the client, it was their first time interacting with this stuff. And then we do it for all the other designs and patterns once we've kind of nailed down what the overall look is going to be. Once we do that, we'll go through, and then we might edit some of the fabrics. Oh, this is a bit too many wrinkles, too little wrinkles. Can you open up the zipper from the bottom or from the top? And we'll do some of those simulations and hold that in place until we get the right look that they're looking for. And you can see that it's an unnatural, abstract kind of pose, but for the camera angle that we've already established, it's the right one for them. And you'll see in the bottom, sometimes when we're spinning around, there's a lot of pins holding back. It's a typical thing, as even if you're doing photography, you'll have to still pin some of these clothing just to make things look fit the right way. Once we go to Modo, we bring in all the assets and start adding hardware, zippers. We model all that inside of Modo itself, whether it's a texture that needs to be on top of a plane or actual models. And we'll fit that to the form that we're conforming to, which was pretty cool. You'll see here, like this zipper has a rubber portion that was snugly constrained to the surface, which was pretty cool. Illustrator work, just to get all the stitching. So we'll grab the UV map from Modo, export that out, and then we'll do all the stitching on top, and then we'll do additional blending options like drop shadows and glows and piping, all that to go back into Modo for displacement, bump, or any other, or material masking, or whatever we want. We use ZBrush. Jessica Kim, who unfortunately wasn't here, she said she could be, but she would basically grab our references and then sculpt all the rest of the details, like the small tiny wrinkles and the pulls and the pull downs from the stitching itself. You can see the amount of detail that she'd go through just to get all that in. And we'd take all that information and then remap that on top of our surface to get the final look for the jacket. Oh, the swacket, sorry. And you can see on the left side, kind of that's before and then after we've added it on there. And we try to match as closely as possible to all the real values and scale. These are some of the images that we use to kind of finalize all the different material presets. So bump maps, displacement maps, normal maps, I mean, anything to make it look good. That's what we're trying to achieve here, just to kind of sell the idea and the design to the client. Again, just using one of the 9-ball preset scenes where it's got kind of calibrated lighting. We're bringing all the textures in there, make sure scale is correct. We'll test the scale of everything inside of the scene, export that out, and then move on over to lighting. And obviously with Modo's progressive render, which is what we use most of the time, is just we render everything progressively, and we look at, how does it look like from one side to another, and then we bring it all together to kind of get to the final effect of all that lighting. It allows us a fluid way of working and getting customer review and feedback pretty quickly. Once we're happy with it, we lock it, and we actually lock it for we locked it for all of these different fabrics except for the white one because you have to tone down some of the lighting for that. We'll check some of the details just to make sure everything is working. Like I said, you are zooming. This is exactly the level that they'll be seeing it in, so you do have to zoom to that and see whether or not you're actually getting what you need. And then we take it over to Photoshop, double check there's no issues once everything is done. The water droplets were added, some of the effects that you see are added on top, but the actual water droplets on the surface were done inside of Modo, which I'll show in a second. So the water drop system was kind of interesting because we had 4 or 5 different replication systems. This one is based on kind of, we did a bunch of different water drops and then manually placed them, and not only placed them, but we actually also oriented them, because doing a simulation was just not going to be something we're going to do and deal with. So it was much better if we artistically moved those droplets. The coolest thing is after we did one of the simulations, we actually grabbed the droplets and then literally slid them on the surface with a background constraint, and all the droplets were flowing correctly after that. And then we'll use additional hero drops to place on top. So we had a replicator for like large drops, small drops, hero drops, and then finally our hand-drawn ones. And you can see them all here on top of the surface. They look like there's a lot of them, but they're water, they're transparent. So you're just trying to grab a little bit of specular on top of the surface. The cool thing about Modo is that I can now grab every one of those droplets and change size and show the client, okay, I need it smaller, bigger, pretty quickly and pretty easily. And then everything, again, gets dropped on top. My compound, again, would take this and kind of do the retouching on top just to make sure everything is spit and span exactly how the client wants and expects for their final delivery. But that's basically the Swacket project. I'm going to show you some interesting things that we've done with Modo, unrelated to the Swacket, but we've done some, I like to create tools to create designs, not just actually just do the designs themselves in the production. So we worked on an eyewear production tool that designers don't actually have to model 3D at all. All they do is edit curves in Illustrator, specifically the stem, the frame, and the lens, and then export it out, and you actually get out of the box a procedurally created eyewear frame. And what that allows you to do inside of Modo 10 is I can now either just go back to Illustrator and update my curves and pump it out, and I don't model anything. Everything is done for me. Even the lenses themselves are done. The grooves where the lenses will kind of pop in are done. The stems are done. I can change the lens radius after the fact. All of that done in a post-process where the designer doesn't need to learn how to do 3D. Same thing for nose bridge and nose pads and whatnot. I think the power of this is that, again, you could have 1 or 2 people that are kind of super users who understand how to rig all this stuff up, but the designer just needs to know Illustrator, which is what they do right now. And we export to kind of the partners that you guys talked about before, which is Sketchfab. You just go to the web. You can do this, and it's kind of funny. We've created these eyewear model with VR, so you can actually go in and look at it from a real perspective with an actual model in there, and it's just on the web, which is insane. And that's it. That's my presentation.
Awesome. So yeah, I think thanks again, Yazan. A really key point that I think both you and Ed hit on really well is how these rigs, these really modeling rigs in a certain sense, are feeders to additional designers that completely have no experience with Modo, but can go in there and be creative with very little input and have a lot of flexibility in the end result of the design.
Yeah.
Because many of these things are let's face it, they're rigid in what the glasses have to fit on a face. The face has a standard form.
Right.
But you can design around that very fluidly with these rigs.
Yeah, and that's the thing that they did not have before. They would basically model on top of an average face. Now they can bring in a 3D, an actual person scan. They can work on something different. It allows them the flexibility to explore without having to learn everything from scratch.
Very cool stuff. Thank you. Thank you again. All right, so to shift gears a little bit, we're going to move into a few of our entertainment customers. First up, we have a couple of guys from Boxel Studios, Andreas and Juris. Come on up, guys. Take a seat. Andreas is the CEO of Boxel, and Juris is the production manager of Boxel. Boxel has a couple different offices. One here in LA.
Yes.
Another one in
Tijuana, yes.
Tijuana,
Mexico.
Mexico. I think what these guys have done for the CG business in Mexico alone is very amazing. They're one of the first really big studios, especially in Tijuana, and it really started to grow out the business of computer graphics and film production and CG production throughout Mexico. in a very big way. But they're going to talk to you a little bit about how they use Modo and Nuke and some of our other tools across film production. So take it away, guys.
Yeah, thank you. Thank you so much for having us. So we're grateful with Foundry for giving us all the support that they have given us. I think the most important thing that I will not to forget is the reason that we fell in love with Modo is because of the community. I think something that is very important, as you're seeing in previous presentations, is we're in good times of 3D. Believe me, being the founder of this company back in the days when you're doing 3D and in DOS, typing text in order to get a model, and now just clicking a button, achieving so much, I think it's great times right now. And on top of that, having a company like the Foundry that really focuses on building technology that empowers the artist, I think that's just, they're second to none. They're the best company for us to work with. So, and I'll just move ahead. So Boxel Studios, it's a fairly new studio, founded in 2008. We've have a bit over 100 artists working our facility. We just recently announced our merger with JV with Film Roman. Film Roman, world-renowned production company for over 30 years, doing production and entertainment for like Simpsons, Family Guy, King of the Hill. And us having a little bit over 15 years of experience with the founders, I think, as Shane was saying, having offices in LA and having production headquarters in Tijuana just makes sense. So in this presentation, we're going to talk about why Modo, why are we using Modo and Foundry pipeline as our pipeline within the studio. And one thing that I want to start with is it all starts with having a character that is going to go on scene, and you need to model it. And for us, Modo, for modeling, it should be the modeler of choice, period, for every modeler in every studio. It's just so simple to use, so easy to learn. And in this case, we're Alma, because I asked some of our artists from the studio to build some of demos. So this is Alma, our lead modeler, graphic designer background. They go through our internal training program, which is a 2-week program. And within 2 weeks, a graphic designer that has a clear understanding of how an image should look in volume, all of a sudden it's modeling like a pro. And on top of that, it's working towards building a character that's going to be approved, in this case, by a brand. In this case, we're going to talk about a little bit of our current project that we're working, which is Max Steel for Mattel. So these guys make toys, and from the toy, they have the manufacturing toy. So what we ask for the brand is, give us a toy, and we can, with the Retopo tools, we can make the entertainment model. And what this does for us, we can showcase super fast, we can make errors super fast and show the director how the model is going to actually look in CG, but we also have the practice internally that all of our modelers have access to at least 2 Formlabs printers, and you just basically model the thing, export an STL, get it into the Formlabs software, boom, you're ready to go. I make it sound more easier, but Alma is really the magician there on knowing exactly what to do and how to rotate the object, but the results are just amazing.
Well, now let's talk about rigging. The rigging tools inside Modo are just great. And, well, take it from me, I'm not an engineer. My background is in design. And I can really tell that the rigging tools inside Modo are the perfect balance between the artistic tools and the technological tools. So, for example, for this project, what we basically did is we created a basic structure rig with all the features that we needed for the production. We saved this as an assembly, and that's it. You have a fully functional rig. The only thing left to do is actually click and drag, adjust proportions, and that's it. You have a fully functional rig under 40 minutes. And then you have time for the really, really fun part, which is the facial rig. Which, by the way, this is not speed ramp. That's the actual performance of the rig on a laptop, by the way. Now, moving on to the facial rig, it's pretty basic. It's pretty much morph deformers and transformer deformers. But what's really cool about it is that the way Modo works is that you have your morphs layered. So if the director comes in and asks you for maybe tweak some facial expression, it's pretty simple, really. You don't really have to go back and disconnect the controllers. You just go back, tweak it, and instantaneously it's already connected. So if you structure the way that your rig really organized, it's really simple to adjust every step of the way.
And again, I think something very important to showcase here. This is what we internally call a layout rig. And it all comes together. In this particular case, something to note is that we really want to give our director an easier way to make changes at an earlier stage. In this case, our internal process is final layout animatic, which is basically going from storyboard to the layout, avoiding going through a locked animatic because you're working on a CG feature and things will convert differently in 3D space. And in this particular situation, as Gidis was saying, you're using layouts with 5 characters on set, on a scene. You're having your supervisor director, you're supervising the show, and your artists are working under a $2,000 laptop, which is, I think, that's very important regarding efficiency on the software.
And now moving on to dynamics, I think this is a really important step because people don't really think about Modo when they think about dynamics, but we at Boxel, we do. We think of a pipeline from A to Z inside Modo, and Dynamics is no exception to it. I think it has proved to be really efficient, and more important, it looks awesome. So it's really simple. In this case, it's just a single plane. You shatter it. You add the dynamics to those pieces, add the collision, and that's it. You're just a couple of clicks away from having an awesome dynamic. And going back again, this is running in real time. That's how long it took to run the simulation, which is pretty fast. It's
on
amazing.
a laptop.
On a laptop.
And also something that I forgot to mention. In this particular case, we're working on four episodes of 22 minutes. This project we're currently working on, like literally today, we're delivering the first 2 episodes. And the project was signed last September. So we have September, October, November, and December to deliver 44 minutes of full CG animation, from modeling to rigging to lighting to shading, the complete show in full CG. I think that if you don't have the right tool to deliver that in that fast production, you have to put a lot of attention. I think that this is where Modo really, really, really thrives. And in this case, I think it's important to show, this is from the Americano the movie, which is a feature. We had much more time, which we develop our internal pipeline. All the modelers, once they finish, like in preschool, they finish the model, they assign selection sets, which this part goes this material, this part goes with other materials, and we have an internal programmer, and he programs a specific tool called sets to materials. So those selection sets are converted immediately with just one click into material groups, which makes it super easy for a shading artist to basically click and drag. If you have the right nomenclature, in this case, when you don't have time, when you need consistency, and when you are working with a limited budget, what you don't have is this organization. You have to be very organized. So what we do put a lot of attention into our pipeline is nomenclature. And in this case, El Americano underscore the name of the character, underscore the name of whatever part it is, and then we generate preset materials. And once we generate the preset materials, basically what you're doing is guaranteeing consistency through all of your shots. And the reason that for our pipeline works is some of our animators work in different animation packages. And this is something that we love about Modo. It just plays nice with any other package through the Alembic format. And in this case, all of the geometry is the same. The characters and the topology are the same, that it's shared with different platforms. But when it gets back with the master model and we're plugging that it's called Materialize, basically you just assign all of your preset materials. In this case, you're looking at the preset materials for Max Steel, which is the plastic of rain, this is the rain character, which is metal, which is the visor material. And once that's finished, just click a button and boom, you're done. And when you import the characters, they automatically are materialized in every shot. What we're going to showcase here is I think what everybody else is talking about, which is amazing, is a progressive renderer. Once you're done and you have your lighting rig, in this case we have our lighting rig that we rotate around the character, we give it 5 seconds, literally 5 seconds. That's speed ramp. You run your progressive renderer, and I can I'm going to do it because I think it's important. I'll go back. The only part that it was speed ramp was that part. Let me show you. There, once it's there, like options, animation, 5 seconds, 192 frames, click OK. And that's the part that's speed ramp. The other is 5 seconds per frame. You're talking about a 2K render. Right there, where what we want to see is the lighting to shading reaction and the shading to lighting reaction, so you don't have any types of surprises. At the end of the day, you're going to have 5 characters on a scene, and you really want to know how the shaders are going to react, because as we all know, when you're doing in CG and materials, you're going to have some sort of artifacts during your process, so you really have to be doing a lot of troubleshooting prior to getting into the actual shot. And in this part, which is together, lighting, something that we want to showcase here, this is Hugo, one of our lighting directors. He's a film background artist, has 28 years of age, never touched a 3D software. He incorporated into our studio in September because we needed a cinematographer that really cared for the look and feel of the film. And went through a two-week training program and applied really his knowledge about lighting and cinematography and lens selection. And he started just learning, where do I add a light? How do I change the Kelvin of a light? How do I move myself within the environment? That's the only thing that I need to learn. And for him, looking at parameters in the camera and changing lens to 28 millimeters and the focal distance and everything speaks film for him, doesn't speak computer graphics or science. I think that's the most powerful thing. To have an artist that is really good at lighting and live action cinematography and enable him through technology to do imagery for CG, I think that's the most powerful thing. And then you show them to a live action photographer that you can light link a scene, they light link the scene all over the place, because they really a light can only light a certain scene. And as you can see, the renderer can give you imagery that it's not necessarily looks like the same. Like, oh, that was rendered in this. No, you can tweak it so much, then you can really achieve unique render styles.
And well, having this kind of productions really helped us to be more efficient with our tools and the use of it. And here's where scripting came to play. We have a couple of plugins, in-house plugins that our in-house programmer Angel did actually. This is one of those examples. This is an offset tool that he developed for our rigging team, which is great, by the way. I personally asked for it. It's really simple, actually, but it saves a lot of time. When you're rigging, for example, a hand, and you need to add different presets, like a fist, open the spans, or anyhow, you need to add locators, overlocators to overlocators, and repeat this process. And here's where the offset came into play. And we asked our in-house programmer to do this, and in a matter of minutes, he solved it, because the scripting tools inside Modo are quick, are fast, and they work great.
Yeah, I think something super important here is that when I'm showcasing here in the interface, you have a command. And everything that you're doing in Modo, it's basically showing you what it did. And with a little bit of logic, let me pause here. With a little bit of logic, your programmer can be submitting for review a script within an hour or within 2 hours. So again, I think that you can feel it and smell it in Modo. Like the programmers really put a lot of thought into making a tool that will, like the way that they're thinking, presets, a button that can help you do something faster. They're thinking as filmmakers, and I think that's something very important. In our line of business, really people don't care what software you use to finish a show. They care about the show. Is it good? Is it engaging? Does it look good? They really don't care which tool you use. They care that it's good. So if you really think about that, we're not longer in the area where, oh, if you're not using that, it's not going to be good. No, it's going to be good if it really pushes the artist to the limit in delivering the best work that can ever do, and I think that's where Modo really thrives. And in this case, GDs will explain a little bit about how Modo and Nuke now come together. And particularly, we're talking about Max Steel. Max Steel basically can transform to whatever he wants to transform. So again, in 44 minutes of animation, you have to transform him into different type of modes, and you have to come up with a very difficult transformation. And this is where I think Modo and Nuke came into play. So if you can...
Well, we already know that, that the Modo render engine is awesome. We know it creates great imagery, it's fast, it can be as photoreal or as cartoon as you like. But when you mix this with Nuke, it's just, there's no match, I think. It's a perfect man for the job when you mix those two. And for this example, we had to transform Max into different modes. When we're picking our fights, we say on what we're going to render out of the box from Modo and what we're going to achieve mixing it with Nuke. We took advantage of all of the tools that Nuke has to offer. And for example, we use the volume rays to create volumetric lighting effects, which are really cost-effective render-wise on render time. And they also look awesome because you can make them interact with the characters with the help of an alpha channel, and you can break the volume rays with just a noise. So you can create really awesome volumetric light effects really quick and easy.
Correct. And then we'll see here, we also have a division that works in live action. So for example, in this show for Roots that aired for A&E last Memorial Day, as simple as a box here. Sorry, this is super grotesque, but it's important to show. As simple as the director forgot to put a box in front. And this is what we're calling invisible effects, that nobody should know that they were there at all. You should think that they were there from the get-go. But the director forgot a box there, right? You model it, you shade it, you light it photorealistically, and then you composite it over, and that's it. And in this case, they forgot to break the bone and model a little bone and put it there. They cannot compromise this actress with a beehive, and you have to break the beehive, but the beehive was never there, was never broken. The actress should hit that and be basically attacked by these bees. You model the bee, you animate the bee in Modo, you use your replication system, particle systems, Nuke, boom, you're there. And the same here. We have a pond, we have this actress. Oh, we forgot the fish. They're periodic in 1920 in Louisiana, and we need to model a specific type of fish, and we need to shade that fish, and we need to replicate it and use the particle system. And here is a one-stop shop. It's just Modo, modeling, animating, rigging it, shading it, and then in Nuke just putting the cards in and making this pond look great. So in some of the projects that we've collaborated, this is what we have found, and I think this is important. This is a conclusion that I wrote here in Spanish. Sorry for our Spanglish here. Hopefully I'll get it right now. But this is so far what we've concluded. What we concluded is that we're working with image creators and story creators. And those guys are visionaries. And those visionaries require great team of artists, which some of our artists are here, and I will never be as grateful as I am with you guys because I think you accomplished so much in so little time. And these teams are going to spend a lot of time in the computer. They're going to have red eye, and they're going to be working long hours every day, and they're going to be working on a piece of software. So you really want your artist to be working on a piece of software that it's a joy to work with. And I think all of our artists, that's why we don't say I love Modo, we say we love Modo. So thank you so much, Foundry. Thank you so much for
Thank you for having us.
I've seen that already, and it still blows me away every single time. I love the passion, guys. I really love the passion. I really appreciate all that you do. There's literally no part of Modo you don't use, it seems like. You're end-to-end everywhere about it. The most amazing thing to me is how you're able to take a laptop, a tablet from Wacom, an artist that's traditionally trained and been doing nothing computer-related for their entire career,
yes.
Sit them down in what?
2 weeks.
Weeks time.
Yeah.
they're productive in the tool. That just completely blows me away.
Good times.
You guys are doing really, really high-end stuff, so I appreciate it.
Thank you. Thank you, guys.
Thank you.
All right, so next up we have Connor Campbell from BatterCry Studios to represent what some of the Modo games customers have been doing recently with the tool. Connor has worked at a number of different studios in his career so far. He's currently down in Austin, Texas, and does mostly prop modeling, environment modeling, worked on the latest version of Doom and some environments there as well. So without further ado, I'm going to let Connor take you through some of the cool stuff that he does with Modo and games. Thanks, Connor.
All right. Thank you, Shane. Hey guys, I'm Connor McCampbell. I've been working in the film and game industry for a little over 4 years now, and I've had the opportunity to work with pretty much every single 3D package in a professional capacity, and I'm here today to talk about why I think Modo is the best one for real-time art. So these are just a small subset of companies that I personally know of, just to give you an idea of how prolific Modo has become in the game industry. And these are just some studios that are either using it for content creation or as their primary 3D package with direct engine integration. At BatterCry, we recently had the chance to work with Ed on the latest Doom, and this is some of the work that we've done with them. So Ed uses Modo heavily in world building and asset creation and level design, and it's a cool thing to note that everything in these images right here was built entirely within Modo and then exported as just a couple chunks to build up the entire level in Doom. This asset right here is actually made using just a bunch of primitive geometry and booleans and bevels, and one of my favorite features in Modo, which is the rounded edge shader, which I'll be going into detail about a little bit later. This gun was made using Mesh Fusion, which you saw Kevin and Ed talk a little bit about earlier for when you need to create sub-D geometry and keep it really highly editable and live for iterating. Super powerful workflow. And these last two models right here were also made using the rounded edge shader, which is actually fully bakeable down to low-res geometry to create game-ready assets too. So it's a super powerful workflow to be able to keep things really lightweight and editable, but still ended up with a game-res mesh. So why Modo? What about Modo makes the software so conducive to creating real-time art? First and foremost, it's absolutely objectively the most artist-friendly 3D package there is. And a large part of that is because of its best-in-class modeling and UVing tools. If you're involved in creating art for games in any capacity, you know how much of time that actually takes up. So it's an incredibly important thing to have. So things like the selection tools, action centers for pivot control, work plane to be able to create and pull geometry off of any normal, fall-offs, which is a more powerful version of lattice tools or freeform deform tools that can be stacked and combined with their tools. Integrated sculpting tools, which are actually fantastic and work really well. I'll be going into detail about those a little bit later too and how we use some of those on Doom. Automatic retopology, which is basically Dynamesh right inside of Modo. It's fantastic. Powerful booleans, being able to just work with all of this stuff in a modern and clean user interface that's consistent is great too. And the freedom to work with n-gons and just irregular geometry while having your mesh retain all of its properties and not become unworkable is really liberating. Macro creation is another one of my favorite things, where everyone in here, you can basically be your own programmer without having to know any scripting knowledge at all. The rounded edge shader, screen space activated tools, so you don't have to snipe out geometry to move things on certain axes, and cutting and pasting. All these things are just fantastic. And everything over here on the right is just an honest bonus. Being able to fly through your environment with WASD navigation like you would in the engine, the Game Tools tab, one-to-one parity between materials in Modo and engines. So this right here is my favorite workflow of all of them. This is just using the rounded edge shader. So that's what it looks like. It's just some booleans, geometry crashing together, and this is ultimately what it looks like when you go to render it in Modo's renderer. And the best thing about this is it's super easy to work with, and it's fully bakeable down to low-res geometry. So you can use this in a game workflow too. So this is a little bit more of a complicated example of something I'm working on right now. It's currently a work in progress. But this is exclusively utilizing the rounded edge shader. There's not a single piece of sub-D geometry in this entire thing. So you can really kind of start to see how powerful it is to be able to basically make a blockout mesh, have that also be your high-res version, and be able to just go over in the Modo render preview and get an idea of what your mesh will look like with those nice rounded edges that a bake would give you without having to even make high-res surface geometry. And this is what the geo for that looks like. So not what you'd expect. It's super simple to work with. It's lightweight, and it's really easy to go forward and backward and iterate on this stuff too. And so this is just an example of what this process looks like and what it looks like to work with a rounded edge shader. So all we're doing here is just doing some bevels, not worrying about ingons, booleans. We're just going to cut some stuff in here, do a couple more bevels right inside of that, cut a couple more shapes out, and all of this stuff, none of this matters. You don't need to ever have any kind of a thought about topology or anything. Modo takes care of everything for you. And that's it right there. So that's all you need to do. And we're going to go over a little bit more of a complex example of that later on and learn how to bake that down to low-res geometry, which is a super simple workflow too. So, you might traditionally think that it's hard to step back and, you've done a bunch of Booleans and stuff, and now your geometry is unusable and you've got to start deleting stuff or starting over. But that's absolutely not true with Modo. And in fact, I'm only using one tool here to just completely obliterate all the geometry that I've added or subtracted onto this surface. So this is a really good way to step back through your mesh, change things, not feel afraid to make cuts or changes or Booleans. And it's also a good way to make a low-res version of whatever you're working on for when you're actually getting to the point where you're ready to put it in Engine, bake it down, make a low-res game version. And I'm only using about 3 or 4 different tools here to do all this stuff. This one right here is one of my favorites. I use this all the time when I'm making low-res geometry for games. Unbevel. Just unbevels everything perfectly. And so I just want to talk really quickly about scene and mesh management. This is something that I think is kind of just really underappreciated in Modo. It's super simple but awesome. So this is the way I build all my scenes right here. Is I'll have my standard mesh layer on the left, and I'll have an instance of it on the right. And instead of having to go through any kind of attaching, detaching, combining, separating with a bunch of dirty history and stuff, all you have to do is just click the layer that you want to create geometry in and start making geometry. And if you want to move it between layers, just cut and paste. So macros is another huge thing that I've been using lately more and more at work. Basically what this is it just lets you, just like a Photoshop action, you can start recording something, perform a bunch of different actions, and save that out as a macro. So this really empowers anyone and everyone just to be able to make their own scripts and speed up their own workflow in a bunch of different ways. So right here I just made one that will automatically, without even doing one single click, just select all the hard edges on a geometry and bring me right into the UV window where I can go ahead and just start laying that stuff out. And that's all there is to it. And so right here, I've made a separate macro that will take geometry that's underneath whatever my cursor is hovering over, copy it without even clicking, and I'll hover my mouse over another piece of geometry, and without even clicking again, I'll just press my hotkey, and it will duplicate and propagate those UVs across different pieces of geometry. So that's something that's super useful when you're doing stuff like modular building and games, when you've got UVs that you're going to propagate across a high poly mesh or something. So let's just see how you bake that stuff down. So I've taken the door out of that rendered example right there, and we're just going to go through and use some of Modo's selection tools and other tools to see how we're going to make a low-res version of that and bake that geometry down. So what you're seeing right here is actually that's the high poly geometry right there. It's just a bunch of, it's just geo crashed another geo, ingons, just a bunch of bevels. And so right here we're just using Modo's step tool, which is a tool that just will it'll select the next logical step after 2 components that you selected. It's great for creating low polys too. That right there is it's an align to furthest of left, right, up, or down, but based on what you're looking at your screen, which is one of the best tools I've ever used. I've known people that completely made the switch to Modo based on just one tool like that alone. So it really is just a matter of finding that one thing that really just wows you and running with it. So right here we'll just continue on deleting a few more edges, making this low poly. And that is, so we'll take this and just do a quick additive Boolean. Nothing got ruined there. The geometry is all preserved. Everything is still perfectly functional. We'll just weld those verts together to create one solid airtight mesh. And delete these final 2 edges right here to finish our low poly out. And that's it right there. That's so that's going to work for our low poly. So for the UV tools right here, these are absolutely one of the best parts of Modo for me. Super easy to use. I have all of my UV tools that I use. I use about 4 total, and I have them all in a pie menu. So right here, this one in particular, You can take anything and just make it a perfect rectangle, perfectly spaced edges, and perfectly unfolded. That's something that's completely invaluable for doing stuff like strip texturing when you're working in games and you have a lot of modular textures with different broken up sections that you need to wrap across a bunch of geometry. Super handy, super useful. We'll do the same thing right here too. You should just make those into nice rectangles right away, one click. It works every single time. And so the way I unwrap a lot of my stuff is I'll just go ahead and select edges and just run the unwrap command, and it will make my shells. And all I have to do, run the rectangle tool or run a relax, and then just orient and pack, which will automatically shape my UV shells proportional to the X or Y axis. So we're just doing the same thing right here, a little bit more of that, and we're going to run the command on this. And I'm going to go in here and clean up a couple of the triangles. Super easy, just using the same command that I was using on that Boolean object earlier to clean up the geometry. What it does is just combines everything into whatever you have selected. It's called the polymerge command. It's fantastic too. And we'll just make those into rectangles and finish out our low poly UVs with this right here. So this is another really cool thing is you can use face selections to add to your edge selections. So it's something I'll do a lot is I'll select a loop of faces and then grow that selection and then convert that to edges and keep adding edges on top of that, going back and forth between faces and edges. And that's it for the low poly UVs. I think I just split this in half just to get a little bit more resolution out of this pack, and that's it. So we're going to step through the baking process now, which is also incredibly easy and super streamlined in Modo 10. So the first thing we'll do is just run a quick script right there, and it converts all of your UV border edges to hard edges. Just one button, built right in. Right here, we're going to make our cage. All you do is make a new morph map, click on it, and run the push tool directly on top of your low poly. This is the low poly that we're baking to right here. So all you have to do is just click back and forth. That's it. No managing an external cage file or exporting another FBX. And so we'll come back in here, make a new bake item. We set our target meshes and source meshes, which is the high poly. And we'll come over in here, and in the low poly material, which is the material assigned to the low poly mesh, we're just going to add an image, which is going to be what our bake gets saved on top of. So right here, we'll rename the bake item door bake, select our cage, and select the image that we're going to be baking the normal map on top of. And just check all these boxes. And that's all there is to it. And then we just run bake selected right there, after we make sure that we have our high poly material set on our high res, which has our rounded edge value. And that's it. Normal map, normal bake, just from that alone. So we'll come over here, hide the high poly, and assign the low poly material, and you can see it's got perfectly baked edges as if you had made a high poly mesh for this, except you didn't have to go through the trouble of figuring out topology and breaking that stuff all down to a low res mesh. It's a drastically underappreciated workflow that I think a lot more people need to embrace and know about. So this right here, this is using some of that same automatic retopology stuff that Kevin showed us earlier. If you wanted to make a low poly for this, you quite literally just pull it up and press OK, and there you go, you're done. So there's no going to other programs, there's no manual retopology, you don't have to save earlier versions of something that you did send. That's it, you're done, you're good to go. And you'd use the exact same process to UV and bake this thing too. And so finally, I just want to talk a little bit about the sculpting tools in Modo because they're actually super useful. The brushes in here are great. I think there's about 7 or 8 over here on the left-hand side, and honestly, that's about how many you use anyway. It's got alpha support, but all we're going to do right here is just take a low-res mesh and just kind of start pushing and pulling some stuff around to kind of make a little bit of a rock shape that we're going to use for cutting. And so we're not too worried about getting any cool details out of here, just kind of worried about the overall silhouette. So right here, we'll just add a couple more subdivisions, and there we go. So then we'll take the jitter tool and just add a little bit of undulation into that so it gets a little bit more of a rocky type of look and shape. Duplicate this, and using that same Boolean workflow that we used earlier to get that nice hard surface high-res mesh, we'll just do that same thing right here. Just cut that Boolean right out of that mesh. Do the same thing right here, add a couple more cuts to get some more variation in the shape so we can use this to cut other geometry. We're going to create damage pillars with this. And so right here, we'll just go ahead and do an additive one, just for a little bit more extra variation. And there's no cleanup at all right here. This stuff just absolutely works. It doesn't create a bunch of extra vertices or unusable geometry. It's just good to go, plug and play. So right here, we'll just go ahead and start cutting the stuff out of the mesh. And this is the way that we did a lot of the pillars in those Doom screenshots that I showed earlier, is we just take the stuff and just start Booleaning stuff out. And something interesting about Modo 10 is you can actually do this procedurally now too. So if you add this as a mesh operation, you can actually go back and start pulling this stuff around after the fact if you didn't like the first shape that you made. This is a super, super awesome workflow. You don't have to go into ZBrush and worry about sculpting another version and then coming back and retopologizing that. You can just lay your UVs out on this, just cut your booleans, grab the material that results from creating those damaged edges, and then assign something else to that. So here we'll do it again on this mesh too, and you can see that it's not only useful for just cutting shapes out entirely, but you can also just cut a portion of it out, and it will react just accordingly, just as you'd expect. So we'll just do one more cut right here at the top. And that's it. Go back over here into the game tab, just set some surface normals, and that's all there is to it. It's the fastest way to create damaged edges and stuff that I've ever worked with. So that's it. That's it, guys. Please give this stuff a try. It's awesome.
Thanks, Connor. I must say, you make my job as a product manager really, really tough. Everything that you need is there, and you're able to take that and refine that in such a way to make it, almost down to a point where you don't even need a hotkey. You're instantly just selecting and doing. But I'll let you know, challenge accepted. We are working very hard to continue to improve a lot of those workflows, even further refine them. That's a big part of what we're focused on this year is taking those mundane steps and reducing them and letting the tool get out of the way of the artist and be more productive. So you're a great example of that. Good job. Thanks.
Thank you.
All right. On that similar theme, up next we have Adam Ahern from Mechanical Color. Adam is another unique breed of Modo user. He is a production artist as well, does a number of things as a freelancer in that aspect. But he also creates a number of really, really amazing kits and plugins for Modo that further extend it and further automate it for particular workflows. So I really wanted Adam to come up here and show you guys how you can change Modo. You could adapt Modo to your particular workflow, much like you've seen some of these guys do with just simple macros and things like that. But Adam, as a trained artist, has been able to go even further into Python, into the regular SDK, to no man's land, right? And no artist land, that's for sure. But really, really punch it to a different level and create an amazing portfolio of plugins. So take it away, Adam.
Thanks, Shane. Like Shane said, my name's Adam from Mechanical Color. We specialize in product design visualization. About 80% of that work is like virtual photography for press, packaging, billboards, point-of-purchase displays. We do product animation for television and web and retail kiosks, and even a little bit of VR for design reviews and demos and simulations and things with clients. And product visualization is not really the same as typical VFX work for several reasons. I mean, of course, we have a specialized knowledge of industrial design storytelling as opposed to other kinds of storytelling, and traditional product photography techniques. But also, from a technical perspective, we have a kind of a unique look at 3D CAD and building 3D CAD-centric visualization workflows. As you can see here, Oculus was a big client of ours in 2016. Most of the images and animations of the Rift and peripherals that you've seen are all animated and rendered in Modo, and most of the images that you're seeing here are come out of Modo just as they are, with zero post-processing, which is amazing for consistency. And when you're doing a big brand rollout like Oculus, consistency is everything. And so that's why Modo is at the core of what we do. We can use these three main reasons: presets, customization, and extensibility to keep everything nice and consistent. We devote about a quarter of our time to development work for visualization workflows specifically. I'm a designer, as Shane said, not a developer, but I was able to work this out myself and extend Modo to a pretty surprising extent. And we've even built a nice little side business selling plugins, kits, and training for Modo. And about 20% of our revenue last year was selling retail plugins, kits, and training. I'm going to give a little demo of some of what we're doing here. and show a few examples. So let's say we're doing this quadcopter. We need to do a nice studio shot for it, or several nice shots. This is the default Modo UI, of course, but we can switch over to the mechanical color UI called Zen. It's one of our most popular products. It's what we're most known for in the community, I think. And we're going to set up this shot a little bit. Now, I'm using Modo 902 in this demo. Everything you're going to see here works way better in Modo 10. So just go check it out at mechanicalcolor.com. You'll see even better stuff. Here I'm setting up a quick little layout just to do a demo here. But you'll see, like, I'm going to slash through this and make changes on the fly to my layout, which is pretty amazing in Modo. Now, Kelvin is our studio photography kit in Modo. Studio photography is obviously a huge part of what we do. And so this one is actually really important to our work. And it's probably our second most popular kit. It's really fantastic. Here I'm just dropping in a really basic ramp for a typical studio shot. And it asks you for the scene scale when you drop it in, so you don't have to do any scaling after the fact. The default scene has a directional light and a glowing environment by default. So I have a preset that just blacks it out for us. In one click, we don't have to do any extra work. Now we're starting from a blank black studio. Now, next I'm going to hide the ramp. And one nice thing about the mechanical or the Kelvin preset is that the ramp, even if you hide it in the viewport, it remains visible in the render. So you don't have to dirty up your viewport with all that extra environmental stuff. So here I'm going to drop in our hybrid 3-point light rig. We've got a bunch of different light rigs. This one's a really common one. I use this one. This is probably my most used lighting rig. And you can scale the entire rig and rotate it, or, of course, move and scale the individual lights really easily. It's very straightforward, and that's what we're going for with Kelvin. Just keep it simple. Next, the image looks a little bit dark. I'm going to hide the camera, just get that out of the way, and then show my assemblies here. And I have a color card. This is just a typical Greta Macbeth calibration card. And when we bring this in, the point here is consistency. So if I'm going to do a lot of shots of a given product, I need my materials to work well in all of those shots. You don't want to be adjusting and tweaking materials for each individual shot. So it's important that this key shot have perfectly balanced lighting. So I'm going to position this card in what I consider a really important part of the image, somewhere where the lighting needs to be nice and balanced. Then I'm going to use the cropper plugin for Modo. Once again, just select part of the image, hit one button, and it's going to crop that image for us so that we can zoom in on one part of the image. Now, what's the magic of this color card is that you've got these little circles, and the circles are the true colors of those cards, and then the lit colors are the rectangle. When the circles disappear within the rectangle, you know that your lighting is perfectly balanced. So I just did in about 5 seconds what used to take me a lot of iteration to figure out, like, you know, going back and forth to Photoshop and doing color samples and whatever. It's incredibly straightforward. And you notice as I adjust these lights, all I have to do is click the light and all of the relevant controls show up. I don't have to dig through properties panels at all. We just click that crop button. Now we're back to the full crop. So also, Zen is the UI. It's designed for all screen sizes. I'm using a relatively small laptop monitor here, but a lot of my users are using giant monitors, and what they love about Zen is that everything is under your mouse. So even if you have a huge monitor, you move your mouse all the way to one side, you pop up the toolbar, it's right under your mouse, nice and convenient. I also have tablet users working on even smaller screens than this, and it works great for them as well. So I'm going to open up the render window here. This is the Zen rendering UI. It's really focused around progressive. And we have a render settings panel here that shows only the straight dope. This is the stuff, if you follow Richard Yacht's shading masterclass, these are the things that you need to adjust in order to have a really great image. And we also include render settings presets, so you never have to think about that. I just use the 1280 by 720 final, we're done. And now I can jump here in the rendering UI and click on bucket render if you want to use the bucket renderer. But for still images, and even increasingly for animations, you don't even need the bucket renderer. Don't futz with that. Just go to the full progressive, let it run, and the image will be fantastic. And of course, with all of these progressive renders, it's gonna chug right under your mouse first and foremost. So if I just zoom into this part, I can get a quick preview of what the final image looks like and see that, oh, I forgot to add the pad print to this logo. So we can close this up and go back and start to make a change. Now, I can't see very well what's going on here. The blue is just, it's kind of hiding the lines for me. I'm going to use the Bling plugin for Modo. It's another one that we make to drop in a quick matte cap shader in one click. You don't have to go to the shader tree. You don't have to import any images. You click a button and it shows up. I'm going to choose a nice warm cool here, just a nice warm cool white so that we can see what we're doing. Now, when you import CAD geometry, the polygons are a mess, right? You got a zillion of them. How are we going to select this logo? Well, when you do a CAD import in Modo, a lot of people don't know that the actual CAD faces are stored within the Modo polys as polygon tags. So I can actually just select the individual polygons and use a plugin called Tagger. We have a tool built into Tagger called Flood Select by Part, and that's mapped to control right square bracket by default, so you can really quickly grab that logo. I'm going to hit M for material, and instead of choosing an arbitrary color, I can either do a random color for a quick assignment, or all of my presets are built right into here. So it saves me the step of going to a preset browser. I can just go down here and choose a typical matte black, hit OK, and that's assigned without having to go to look at materials, look at the shader tree, anything like that. It's really straightforward. So once we have that in, I want to talk about another plugin really quickly. The other thing that I want to talk about is called Pacify. So we've got this image. It's pretty good, but of course there's going to be some post work involved most likely. Pacify is our render pass management system. It makes working with passes much faster, much safer, much easier. And we've got some really nice utilities just built right in for typical product shot kind of stuff. So here I'm selecting the ramp, clicking Add to Background, and then I'm going to select the object itself, the quadcopter, and click Add to Foreground. Done. That's all I had to do. Now I've got a foreground pass and a background pass separated out without doing any work with groups, none of that stuff. It's all just done for me. I can click one button to save these out to two separate files, bring them into Photoshop, and composite them. Similarly, with lighting, we have one called Ultralight. Ultralight actually looks through the whole scene, finds anything that's glowing, and creates a pass group for each of those lights. So here I can turn on and off each individual light, and then of course render those out, save them, composite them in post. And if I'm using 32-bit compositing, I can do my relighting in post in real time without having to go back and re-render in Modo. So let's talk about something a little different here. I've got a camera. And I'm going to turn on depth of field. And as you know, with Modo cameras, you can set the depth of field really easily. Just drag a little node around. But it is a manual adjustment, and that stays static. That focal distance doesn't change, even if I move my camera around. So as soon as you move the camera, everything is out of focus. So we have a couple of camera rigs built into Kelvin that are pretty awesome. One of them is called Focus Cam. I use it primarily for still shots. Actually, probably for 90% of my still shots, I use this camera. I'm going to select both cameras, and in Zen, once again, like every tool that we need is built into the Zen toolbar. I'm going to match item position and rotation so that our cameras are matching again, and jump in and change the focal length of this camera, again, just to kind of set that up to what I want it to be to start, and start to frame this shot. Now, the thing about this camera is that it actually gives us a locator item. There's a circular locator in the center there. And as I move that, you'll notice that the gray focal plane is moving along with it. So we get a preview of the focal plane and the crop with the current camera, as well as a static focus location. So as the camera moves, even if it's animated, it's going to stay focused on the right place in my scene without doing any extra work. Now, similarly, there's another thing you often need to do in some of the product shots that I showed at the top here for the Oculus stuff. I need to do this a lot when I'm doing product photography, where I need to simultaneously rotate the product and change from a very dramatic perspective to a very flat orthographic view. And to do that, you really need to change both the focal length and the dolly at the same time. Alfred Hitchcock famously invented that shot in Rear Window, where he kind of gives you vertigo. My job is not to give you vertigo, but the point is, I give you a crop control that's just going to crop the image in and out. That's what I'm showing you here. And then I also give you a dolly control. And when you change the dolly, it simultaneously changes the focal length of the lens so that you can actually animate between a very flat perspective and a very dramatic perspective in a single smooth motion. So this camera I probably use for 90% of my animated shots because it is much more controllable for that kind of thing. So now I want to talk about something totally different. Let's say that I've set up this shot, I've set up several other shots, and I'm ready to render them. Let's talk about Render Monkey. It's our batch rendering plugin for Modo. It's built right into Modo using the Modo UI API. All I have to do is click one button, select some files, hit open, and there they are in my batch. And this is actually being saved as a batch file that we can open later, just so you know. We'll come back to that. We have some parameters here, and all I can do is click render. And I have several presets for half res, quarter res, eighth res, so that you can run a quick example. If you're going to run a large batch render over the weekend, you want to make sure that all your outputs are going the right place. Running a 16th res render really quickly will give you that information, and then you get this nice text file that tells you exactly what it did and whether there were any errors in any of the tasks and all that kind of stuff, so that you'll know before you run it whether it's going to work or not. Now, in this case, by default, it did save these images in a folder that was co-located with the original files, so it's very straightforward. But if you want to fine-tune that, all of that information is configurable within the batch. So we can do arbitrary frame ranges, which Modo can't do by default. Do 1 through 3, 6, 10, and 15 to 20. We can add a different destination, resolution, choose the camera or the pass group we want to use. We can even do things like override the default render command so that you can do things like baking. I have game artists using Render Monkey to do baking operations in batch, which is pretty cool. And of course, you can open these batch files in an external editor. So if you are a technical director running a pipeline, this is a godsend. And all of the documentation comes in by default, so you can very easily see how to set this up. It's pretty great in production. Now, so for more on these plugins and kits, go to mechanicalcolor.com. They're all there with lots of videos for each one. And we have a dozen of them. And we have a package called Dara that contains all of it. We have hundreds of users in all kinds of industries using this stuff right now in production, and they're sending us feedback every single day. I have a bug repository where people file stuff. We fix it within 24 hours pretty much every time. And so this stuff is so much better than it would have been otherwise. I'm also working on a new one called Replay, which is essentially a macro recording graphic UI that's going to make recording and editing and saving and exporting your macros and simple Python scripts super simple and easy. And these days, we also do a lot of custom development work in addition to our production imaging. So for more on anything that we offer, just shoot me an email, adam@mechanicalcolor.com. And yes, of course, you can spell that whichever way you do on your particular island. And yeah, so that's all good.
Love it. Love it. You forgot one thing, though, Adam.
Yeah.
How much? How much is Dara?
Dara is it's $400 pro, $200 non-commercial.
It's ridiculous. That's less than a man day's worth of effort. Yeah. All right. So as we get reset for the kind of the final presentation here, all of you in the audience got free tacos tonight, but one lucky winner online is going to get a free seat of Modo. So I've been told Omar Soho Gutierrez is the lucky winner tonight. So Omar will be in contact with you. Thanks for tuning in and viewing online. And congratulations. So next up we have John Wedelton, our CTO of Foundry, and Greg Brown, a creative specialist for the Foundry as well. And they're going to talk to you a little bit about some future R&D projects. We have a lot of different R&D projects that are constantly going on within the company, leveraging existing technology, looking at new technologies. But I really thought it'd be great to bring John up here to talk about how a lot of people in his core team are taking Modo, the core technology of Modo, and looking at new ways to use it into the future.
Great. Thank you very much, Shane. I'm John. I'm CTO at Foundry, and this is the part of the show where we're going to show you a little sneak peek of some of the things we've been working on in R&D back at HQ. For those of you who don't know, we have a research department at the Foundry, and it looks at a range of different areas, ranging from things like image processing tech and algorithms that you might see in products like NuGex, to rendering technology. Obviously, you see rendering research in Modo, to GPU acceleration, and even like infrastructure stuff like cloud research. As well as that kind of hardcore number crunching type research, we also do proof of concepts or work on workflows or product ideas that are kind of ideas. They're not really fully formed, but we want to take them and explore them and then see where they lead. So this is really what we're talking about today. It's an R&D project, something that we thought was a great idea, and we want to experiment with it, and then we want to share it with people like you to get your feedback and see where it goes to. The particular area of research we're talking about here is VR. VR is really hot right now. Lots of things going on in VR.
Something like that.
There's three main areas at the Foundry that at Foundry, you've got to keep dropping got to start dropping the at Foundry. The three areas are, first of all, live action, 360 video, and pre-rendered 360 content as well. So we're doing a lot of work in that area. If you saw me do one of these sort of previews maybe about 3 years ago, we did a sneak peek of like VR toolset, experimental VR toolset for Nuke to help stitch cameras together and do corrections for the 360 video compositing in that space. And that actually got a really great feedback from people, and we took it and we did a lot more work on it, and we released that as a product last year called Kara VR. It's like a plug-in set to fix problems in 360 stitching and compositing it in 360 space. So that's the first one, live action VR. Second bit we're really interested in is like real time. You know, it's not just 360 video, it's about going into an environment that's fully CG rendered in real time, so with an engine like Unity or Unreal. And on that side, we've got R&D projects going on. I'm not going to talk about them today, but just remind you guys that we've done some good work with Modo and Murray in that regard as well. So if you remember in Modo 10, you had a great pipeline that went from Modo directly to the engine. So you can get the good look in the advanced viewport of the shaders, make it look similar to it does in the game, and then also have a great pipeline where you can go very quickly from one to the other. So those two are about kind of our tools used as content creation tools and workflows to help you make a VR experience. And the third thing that we're really interested in is what can VR do as a tool to help us as designers or 3D artists, or maybe help us as tool makers or filmmakers. So we're interested in that side, because when you think about, films are full of lots of CG and 3D these days, and obviously you're using tools like Modo to create 3D objects. You have to do that through a flat screen, and you have to do it through a window on that 3D world. And as we know, the real world is not like that. The real world is 3D. We walk around rooms all the time, and we interact with things with our hands and do gestures that we don't get to do when we're looking through a window like that in a computer. But VR gives us the opportunity to actually now step into the 3D world, step into the virtual space, and then perhaps use the tools in a more kind of natural way compared to your tablet and looking at a computer screen. So there's lots of examples of this. Stuff like, imagine I'm doing some concept design for a product, and I want to see what that looks like. And the old workflow might be, I'm going to ring up someone and actually get them to build it, and then, if I want to see it in the physical sense, I'm going to have to make a model of it, and that takes a long time. But with VR, you could model something and then put the headset in and see what it looks like in your living room straight away, and then iterate on that. Another example might be like CG animation. If you're doing a CG movie and you're wanting to do some virtual camera work, you have to do that on the flat screen. Again, it's kind of messing with icons and seeing what it looks like through that screen, whereas cameramen in the real world go out with a camera and they walk around and they block out shots. In VR, for CG animation, you can start to do that because you can go into that world and start to block out things. So I've talked a lot. I'm going to hand it over to Greg, who's going to give you a little bit of a sneak peek of this project. It's called, internally at the Foundry, Project Mayhem. Woohoo! Woohoo! Project Mayhem. A bit of R&D, a bit of experimentation about VR and Modo together.
Absolutely. Thank you so much, John. All right. Well, yes, that deserves an applause. And I almost want to applaud again because he let me sit in on these meetings, which was really freaking awesome. All right. So my name is Greg Brown. I'm from the Foundry, as you guys know. And I'm going to show off this research project that we played around with, which is VR inside of Modo. And so just to kind of give you guys a little bit of background, I decided I wanted to be an artist when I was in high school. I had an amazing sculpture professor, got to give it a shout out. His name was Gershon Rappaport. And one day I came into class and I said, hey, Mr. Rapp, I want to work for LucasArts, like typical thing to say in the late 90s, right? Like, I want to be involved in computer graphics. I might as well have said the computer graphics because that's how much I knew about it. And Mr. Rapp actually said, you know what, I'm actually taking a 3D modeling course right now. It's really cool. I'm like, well, what do you mean, 3D modeling? He's like, well, you can build an environment. For example, we could put a car in that environment, and then we could put a unicorn in the tailpipe of that car, and then we could put a camera inside the tailpipe looking at the unicorn, looking out onto the environment. And, my head just kind of tilted sideways like, okay, this guy must have been at like a Pink Floyd concert last night because what he's saying makes absolutely no sense. And as time went on, I kind of realized, especially recently, that what he said made a lot of sense. Because particularly in the case of VR, it's not so much a virtual reality as it is a virtual fantasy or a virtual form of magic. Because while we have this interpretation of reality around us, we're capable of doing everything that we were not capable of doing before in a real environment. I had 800 pounds of clay in my parents' basement. Yes, that basement stunk of mildew, and that cost a lot of money, and I constantly had to rehydrate clay. It was a mess. But that was all to just try and do one single full-size character. And with 3D in general, suddenly I could do it on my desktop. It was a godsend. But now, with VR, I can actually even have that experience of something right in front of me, full size, without the weight. That's kind of magical. And I noticed this when we were having our meetings for the real-time stuff that we were working on, where when we started talking about UI, people started making analogies to superheroes, because that was the only proper analogy you could create. So it was like, wait, no, for the UI, we should have something like Iron Man, where like the HUD is attached to the person as you're looking around, it's following. And then somebody else is like, no, it should be like Jean Grey, where like telekinesis, you just throw stuff out there and it's floating, and like I can just grab it. And it kind of dawned on me that really what people want from VR is this magical fantasy reality. And I think that's really, what we have been trying to pursue here at Foundry as far as this project is concerned, and our pursuit of VR in general. Now, these videos that you're seeing up here right now, this is VR inside of Modo, and you see this side by side. It's very hard to interpret. A company named Illustrator Studios that does a lot of work in VR, they try and explain to people when they do presentations like this, they're like, please understand, if you have not had a VR experience, VR is like salt. If you haven't tasted salt before, you won't be able to understand how it's going to taste. Now, right here, what you're looking at is me interacting in the VR environment, in a game-style environment, where I'm just teleporting on top of a ledge and walking around. And then with pinch-to-zoom navigation that you guys probably are very familiar with already, I can fly out from it and look down and evaluate textures and shading, and then teleport back to real-world scale, evaluate from the start of my level, go over to that rock that's way out in space, teleport on top of this, this rock face right here, and just climb on top of it. And we also even have tools, for instance, like this light tool, which at first I'm like, well, that's kind of silly. But then once I had a cave that was deep in shadow, turned out it was really useful being able to have a light tool, especially for evaluation. And I can select items, check out their wireframes, which is massively important for VR experiences, teleport over, take a look at that wireframe. And yeah, there we go. There's a perfect example of a problem. I've got some texture stretching right in that corner. Probably want to fix that after the fact. But I'm evaluating this by walking around, teleporting, and interacting at real-world scale, which is wonderful. And here's another character. This is Legion Commander from Dota 2. I've played this game. I've seen this character many times. I thought she was a lot bigger than me. I thought she was like 6'6". Turns out she's actually like 5'1". And so completely shifted my perception of this character. And as you can see, I can just navigate around and look at it even from the perspective that you would find in the game. Also, communication, like taking a look at that shoulder. Hey, I want that shoulder to be larger and rounder. This one I want to be smaller, maybe a little bit pointier. And so very easy to communicate to others what you really want from inside this environment. And again, selecting your objects and actually checking out the wireframes. This is vastly important for VR experiences, because when you're actually inside this environment, every flaw, every error becomes extremely obvious. So there's a need for even higher fidelity, greater attention, and VR provides that. And the great thing is I can hop from working in Modo to just looking at it through the VR viewer, back and forth and back and forth. And so we want to emphasize both the desktop experience and VR, and in this case, review. And here's a pulse rifle that I modeled actually for the VR Funhouse, a little webinar I did a while back. And I modeled it all on the desktop, and then I brought it into this VR experience. And I noticed after I did that, I'm like, wow, I would have done things a lot differently. And being able to actually work on it, though, and look at it really changed the experience because I could check out those wireframes. I can zoom in, look at the textures, and decide really where I want to focus my detail. And I can even position myself in a way as though I was really holding this weapon, looking over, sighting down the weapon itself. And I think that is extremely cool because that, adds a level of tangibility that just simply didn't exist before. We're always kind of assuming, like, okay, how's this going to look actually in engine, like once a character's actually holding it. Now I can actually hold it myself. Now here's an architectural visualization example where tabletop model, some of you used to see years ago for ArchiViz. And I can go ahead and just teleport right onto the tabletop, start teleporting throughout the scene. And this wall right here is a perfect example because when I was looking at the model on the desktop, I thought that was a curb. But it turns out it's more like waist height, so it's more of a wall. I can teleport through the entranceway over here, see how I feel about that or how somebody visiting this building would feel. And once I'm happy with that, I can use teleport. And one of my buddies constantly calls this Nightcrawler mode. The superhero references just seem to never end when you're talking about virtual reality. And I can hop over and check out this roof. How do I feel about this? Just things you can't do in the real world, experiences you can't have in a standard desktop experience, which I think is absolutely freaking incredible. This has changed my perspective on how content should be created, and I feel like virtual reality is actually an essential part of content creation in general at this point. So here is my tiny LA apartment. I just moved here a couple months ago. I looked at this apartment, the first apartment I looked at, and a month and a half later I came back and I said, please, please, please give it to me. And so I needed to figure out how to cram a whole lot of furniture in this tiny apartment, right? And I've got to get a Murphy bed. Yes, I really actually have to have a Murphy bed now. I'm kind of ashamed of that. But I needed to find out, does it collide with the ceiling? Stuff like that. I also have a 100-inch screen inside this room, and I need to see how it looks, from a distance, because I'm that guy. I'm going to put a 100-inch screen in a 200-square-foot space. And I can sit down on top of the couch, see how I feel about it. Is this right? I don't know. And so I've evaluated this whole space, and now that I know really, what I want in this space, now I just have to figure out how to pay for it, right? So I can also run animations, and I have some deformers attached to the screen that will, drop it or raise it back up, and I can expose the desk that it actually hides away. So this has really actually allowed me to be much more efficient in laying out what's supposed to be my home, right? And in a way that I would not have been able to do otherwise. So extremely cool ways of being able to even enhance the things I do in my daily life. And here's a wonderful scene that was made by Kevin Ketchum. Thank you, Kevin, because it's a beautiful car, and I can play an animation of this car coming towards me, and this is very important, and there's Modo auto-saving. Thank you for that, Modo. And so I can come over here and take a look at the car from the side, and hey, I want to take a look at the rim. I just kneel down and take a look at the rim the way you would in the real world, and check out the way that lighting is actually affecting the surface and, to really get an idea of what forms I have here. And then I can navigate right on inside of the vehicle and take a look at, what the driver would see or what the passenger would see or, any sort of person in the car would actually experience. And so pretty cool being able to feel like I'll ever be able to afford this freaking car, right? But awesome, awesome way of being able to interact with scenes that typically you would be slightly alienated from just in a desktop experience. And then I can play an animation of the car taking off, zooming off into the distance. Again, important, especially with vehicle design. I also can lean in right along, one of the facets on the car and check out how light plays over that surface. And so, tangibility. This is something that anybody from the past who's done vehicle design for a long time, is what they're going to want to do. And here's Ace Hero. Ace Hero is a character we use for a lot of demos. I put on a little Gnomon-style animation on him from Mixamo. And if there's one thing I'm certain of, after putting this animation on the character, looking at him in a VR experience, I never, ever, ever want to see that again. It was horrific. It was offensive. And so now I can teleport around my character, take a look at it from multiple angles, which has obvious benefits for animation review. And I can even come over here to the front of the character, and I can stop my animation at any point in time. And we added a few different types of play controls here. So we have the ability to step forward and step back and choose a particular frame I want to look at. And then when I want to evaluate deformation, I just lean in and take a look at the deformation in the shoulders and decide, hey, probably need another deformer in that shoulder to try and actually get the look that I want it to actually have. And so just being able to pick up the headset at any point in time and check these things out and then go back to the desktop experience, I think is a pretty spectacular way of working. And so aside from all the awesome stuff that we have in this VR research project, it's also led to tangible improvements to Modo in general. And so I'm going to open up Modo 10.2 right here. And so one of the scenes you saw, the island scene, this, just navigating around it, the regular desktop interface, you can see this was great. The advanced viewport, major improvement for us. But, it had some shadow problems here and there. We definitely wanted to add some higher quality options to the advanced viewport. And if I hop on over into the Modo VR build, just VR research project, I can take a look at the improvements. You can see if I come out here and take a look at the cave, shadows are dramatically improved. And now that is because we now have cascade shadow maps. So if I go ahead and pop this on open, you can see we can choose the number of cascades. We can choose the actual shadow size itself. So a lot more control over the quality. And also, we have options to modify the level of shading. We can hop over into basic shading or even simple and see a very simplified view, because in the case of VR, performance is a massive challenge. We did so much to improve the performance of this viewport for VR. If I could continue coming on down here, take a look at some of the other nice features that we added. Line anti-aliasing is currently set to full. And so if I hop on over, take a look at this wireframe right here, you may not notice the difference immediately, but it has line anti-aliasing enabled on it. And I'll make sure this stays open now. And if I drop this down to off, you can see this is much more similar to what you'd have seen in the past, very alias lines. And so if I go ahead and turn on full, this has a tremendous impact when you have the headset on at any time. Now, also, we have great features that were added, like threaded rendering, HMD resolution scale. By the way, HMD stands for head-mounted display, so you actually can alter the scale of your VR experience to either make it lower resolution for performance, or once we have the hardware that's capable of it, throw it up to 2 or 3 times in super sample and even get higher quality. And on top of that, there's a lot of under-the-hood performance improvements that we also added just for the sake of VR. And so now comparing the quality and performance from this version, this old version, which is 10.2, and the performance improvements that were added during this VR research project, we had like 20 or 30% performance improvement and a dramatic improvement in quality as well. Another thing that we added, if I just zoom on down here to get a nice glancing angle, if I hop on over into 10.2, is texture filtering. If you had a large plane that has repeating textures, as you can see right here, we get this really nasty, jagged kind of alias look. And so we added texture filtering so that doesn't happen anymore. And surprisingly, despite all these additional fidelity improvements, performance on top of all that improved as well. So the research projects that we do at the Foundry, it leads to really cool research projects, such as this VR and Modo research project. But we also try and make sure that it also has tangible benefits for our existing products, things like, Modo. And you will be seeing this in future versions of Modo. And so extremely cool that we're able to work on such, amazing new technology and make sure it benefits our existing users and our existing packages in the way that it does. And so, thank you so much for coming by, listening to us. We're very excited about these projects. And thank you, Duncan Hopkins and Gregory Duquesne, for this awesome work, because you guys are seriously amazing, amazing people.
Thanks a lot. So yeah, it's really, really difficult to get the feel for a VR demo just watching it on a flat screen.
Yes.
It is incredibly difficult. For those of you here in the audience today, we will be shortly setting up this demo so you can actually experience it. You can put on the headset for yourself, give it a whirl, and hopefully throw a few things around. We're mainly focusing at kind of 3 areas of research in the VR project for Modo now, with viewing, with modeling. There's different modeling aspects in there as well, and layout aspects of things. So we're kind of focused on those areas, and hopefully throughout this year we'll be able to present more and more as we advance this. But as Greg mentioned, It isn't just about Modo VR. It's about how we can also just further the core engine of Modo and bring that back into every user, even those that aren't necessarily interested into VR. So thanks again.
Thank you.
And I'd just like to wrap it up. I thank everybody online for hanging out with us for the better part of 2 hours, some into the very wee hours in the morning. Those of you still hanging on in Europe, it's very early there. Those of you in the audience, thank you again. Thank you to our tremendous speakers. We packed a lot into 2 hours tonight, but we wanted to really showcase the total gamut of the types of users, the types of passionate people that are out there using Modo on a day-to-day basis, and I think we successfully did that tonight. So thank you all, and thanks to our sponsors and Gnomon for helping host this for us here tonight as well.